This question is a gear ratio question. We have a bicycler riding and pedaling at 7.6 rads per second. And he, of course, will be pedaling that on the pedal gear right here. And the radius of that gear is 9.1 centimeters. And that chain is attached to the back gear, which is 5.3 centimeters in radius. And of course, all of that attached to a tire right here. Our job is to calculate the mechanical advantage and then finally the linear velocity of the bike. Let's take those gears and represent them in this diagram here. This is our pedal gear of 9.1 centimeters. And the wheel gear is 5.3 centimeters. So essentially what this means is since the front gear is larger than the back gear, this gear here may rotate once, but this must rotate more times in order to keep up with the larger gear. We define that as mechanical advantage. Mechanical advantage, MA, would be equal to the ratio of the first gear divided by the second gear. And we'll use their radius values. The first gear is the one that's being touched by the person pedaling. The second gear is the one that's attached to the wheel. So we'll just do a quick ratio here. We'll take 9.1 centimeters divided by 5.3 centimeters. And of course, we'll cross off the centimeters. So we see that a mechanical advantage has no units. In this case, it's 1.7. So what that means is for every one rotation we have here, there will be 1.7 rotations here. Okay, so then when we do this, let's find the angular velocity of the wheel in the back. So since we're 7.6 right here, we then multiply that by 1.7, and that gives us 13 rads per second. Now what that means is the back gear will be rotating at 13 rads per second while the front gear is at 7.6. Our last thing to find is the linear velocity of the bike, and we could just use V equals RW to find that. So V is equal to the radius of the tire. I'll make that in meters, 0.35 meters. So we'll take 0.35 and multiply that by 13, and we will get 4.6 meters per second. That's how mechanical advantage is used to find the linear velocity of a bike.